Hello everyone, in this video we are going to solve question number 2 of GATE 2013 paper. The question is simple one. It is asked that in the most general case, which one of the following is not a second rank tensor. So in order to solve this question we have to find out what are the different rank of tensor. So tensor is mainly a generalization of simple vector quantities or scalar quantities which you study in physics and mathematics. For example, a tensor with 0 rank are called scalars. Example, your mass, your electric charge Q. So these are all the examples of scalars which are nothing but tensor with 0 rank. Now a tensor with rank 1, they represent vectors. That is, if you want to for example, if you want to study quantity which has one direction associated with it, single direction associated with it, is called the tensor with rank 1. Or in more simple terms, the rank of a tensor is defined with the number of direction required to describe it. So for example, if you have some position vector r, so you need only one direction to describe it. So this is a tensor with rank 1. Similarly, tensor with rank 2, which is they have asked in the question, you require two directions to describe a tensor with rank 2. For example, what you will see in the given question, because in the given question they have asked that which one of the following is not a second rank tensor. So there are three tensors which are second rank and one which is not. So stress, first option, stress. Now stress is nothing but its force per unit area, and there are two directions involved in it. One is the direction of force, first direction, and second is the direction of area. So both these directions are different, therefore it is a second rank tensor. B, strain. Strain is nothing but change in length per unit original length when you apply some kind of force or stress. So there are also two directions involved in it. One is the direction in which the change in length is happening. This is one direction, first direction. The direction in which the change of length is taking place. Another is the direction, second direction is the direction of length. So here also both these two directions are different. So suppose you have some direction, some small some thread which is lying in the xy plane. It's a one-dimensional plane, so it's lying in x direction. So direction of the original length in x direction, but due to some property, its length is changing in some y direction. So there are two directions involved in it. So you apply some kind of force such that the direction in which is changing its length is not x but y. Therefore, there were two directions involved in it, so it's also second rank tensor. Similarly, C, moment of inertia is angular momentum times angular velocity. We know that both this angular momentum and angular velocity have two different directions, can have two different directions. Therefore, it is also a second rank tensor. The pressure is force per unit area, but in the case of this pressure, your directions of force, that is the direction in which you are applying the force, is exactly equal, is in the same direction in which you have the area. So both area and force have same direction. Therefore, there is only one direction in which is involved in this pressure quantity. Therefore, pressure is not a second rank tensor. Pressure is a first order tensor or first rank tensor. Rest all of them are second rank tensor, because in the case of pressure, you have both the force and the, suppose you have some disk and which area vector is lying perpendicular to it, and then force acting is also in the same direction. Therefore, it has only one direction associated with it. So D is that pressure is not a second rank tensor, it is a first rank tensor. Thank you for watching this.